So, you've heard the story. There's this vault. A big, heavy, super secure safe. Inside, a small piece of paper holds one of the most famous secrets in the world, the formula for Coca-Cola. It's a great story. It feels like something out of a movie. But that's only one part of the secret. The real secret, the massive, noisy, always moving secret, is something else entirely. It's not just a recipe, it's a system, a global machine. I wanted to see that machine. So we got in. Before you can even glimpse the production line, there's a strict, non-negotiable ritual. The moment you step on the factory floor, you have to gear up. This isn't just about personal safety, it's about protecting the product from us. Every single person is a potential source of contamination, so the barriers go up immediately. First, the hairnet, ensuring not a single stray hair can find its way into the process. Then, safety glasses to protect the eyes. And finally, a clean white lab coat, buttoned all the way up. There are absolutely no exceptions to this rule. Hygiene is the bedrock of everything that happens here. After gearing up, it's on to a mandatory hand washing and sanitizing station. It's a constant, vigilant process to maintain a near-sterile environment. With that, we can begin. Our first stop on the tour wasn't the famous syrup or the secret ingredients. It was something far more fundamental. The water. It sounds almost boring, doesn't it? Water is just water. But that could not be more wrong. For a beverage like Coca-Cola, water is the very foundation of everything. It makes up over 90% of the final product, acting as the canvas upon which the final flavor is painted. And because of that, they are absolutely obsessed with its purity and consistency. The local water, whether from a municipal source or a private well, is treated in a multi-stage process that is nothing short of remarkable. It starts with sand filters to remove larger particles like silt and sediment. Then, it flows through activated carbon filters, which act like a sponge to absorb chlorine and other organic compounds that could affect the taste. The goal is a completely neutral starting point. The final and most critical step is reverse osmosis. Here, the water is forced under high pressure through a membrane so fine that it strips out almost everything else. Dissolved salts, minerals, microscopic impurities. They strip it down to pure H2O. There are two critical reasons for this obsession. The first is safety, ensuring there are absolutely no harmful impurities. The second is taste. By treating water to this exacting standard, they guarantee that a Coke in Cairo tastes identical to one in Chicago. It's the key to global consistency. We saw the giant, gleaming tanks where this ultra-purified water is held. The maze of polished steel, intricate pipework, and precise gauges gives the entire area a feeling of a NASA-level operation. Next, we move to the syrup. It's a common misconception that each bottling plant makes the secret formula from scratch. In reality, the core of that formula, the concentrate, arrives pre-made and sealed in secure, tamper-evident containers. Inside a highly restricted, access-controlled syrup room, operators combine this precious concentrate with other key ingredients, like sweeteners and purified water, to create the final syrup. This is all done in massive temperature-controlled mixing vessels, equipped with powerful agitators that ensure every drop is perfectly blended. And finally, the bubbles. Carbonation is what gives the drink its signature fizz and bite. This is achieved by chilling the blended liquid to near freezing temperatures, and then injecting it with pure food-grade carbon dioxide under high pressure. The cold temperature is key, as it allows the liquid to absorb and hold more CO2. This carefully controlled process creates the millions of tiny, sharp bubbles that make the final drink so refreshing. Okay, let's talk about the big secret, the formula. For over a century, it's been one of the most captivating stories in business history. A recipe so valuable, it's kept under lock and key in a purpose-built vault. The legend is a cornerstone of the brand's identity, a piece of modern folklore that transforms a simple beverage into a global mystery. Does a handful of people really hold the only copies? The company's story says yes. It's a powerful piece of marketing. A legend. And it works, creating a mystique that no advertising campaign alone could ever achieve. But beyond the marketing, the protection of this formula is rooted in a critical legal and business strategy. In the business world, this is called a trade secret. To understand why this is so important, we need to compare it to its more famous cousin, the patent. When you invent something, you can file for a patent. This gives you an exclusive, government-backed monopoly to make CBM. you same, and sell your invention for a limited time, typically 20 years. But there's a catch. In exchange for that temporary monopoly, you must publicly disclose exactly how your invention works. If the original formula had been patented back in the 1880s, it would have entered the public domain around the time of World War I. Anyone, anywhere, could be making the authentic drink today. By choosing the path of the trade secret, the creators opted for a different kind of protection. A trade secret is any confidential information that gives a business a competitive edge. It can be a formula, a process, or a customer list. Unlike a patent which expires, a trade secret can last forever. But only if you can keep it secret. This is why they are so protective. The entire business model hinges on that secrecy. If the formula leaked, competitors could copy it perfectly, and the unique value proposition would evaporate overnight. This protection isn't just about physical vaults and guards, it extends to a web of legal agreements. Employees with access to sensitive information sign strict non-disclosure agreements. Supply chain partners who handle components of the concentrate are often only given access to a fraction of the process, never the whole picture. It's a strategy of compartmentalization, ensuring no single person or partner holds all the keys to the kingdom. The legal framework is just as robust as the steel vault door. But here's the interesting part, the paradox at the heart of this secret. Much of what's in the drink isn't secret at all. In fact, food labeling laws in most countries require it to be public. Pick up a can and read the label. It's right there, printed for the world to see. This is the part of the story they willingly share. The list of ingredients forms the basic blueprint of the beverage, and it's remarkably consistent across the globe. Let's break it down. First, carbonated water, which makes up over 90% of the product. Then, a sweetener, typically sugar or high fructose corn syrup depending on the region. Next, caramel color, which gives the drink its iconic dark hue. Then, phosphoric acid, which provides a sharp, tangy taste that cuts through the sweetness. And of course, a small amount of caffeine, which adds a mild stimulating effect and a hint of bitterness to the flavor profile. All of these are commodity ingredients, available to any food manufacturer. So if all the main components are public knowledge, where is the secret? It's hidden in plain sight, in two simple words: natural flavors. This unassuming term is a legal catch-all for any flavor derived from a natural source, like a plant or animal. For a beverage company, it's the perfect hiding spot. Natural flavors is the proprietary blend of oils and extracts that gives the drink its unique and hard-to-replicate taste. This is the core of the secret formula, often referred to by its historical code name, merchandise 7X. It's believed to be a complex mixture of citrus oils like orange, lemon, and lime, combined with spices such as nutmeg, cinnamon, and coriander. But even knowing those potential ingredients isn't enough. The true secret, the information locked in the vault, is the recipe. It's not just the what, but the how. What is the exact proportion of each oil? What is the quality specification and origin of each spice? In what order are they blended? At what temperature? For how long? This is the difference between a list of ingredients and a chef's recipe. You can know that a cake contains flour, sugar, and eggs, but only the recipe tells you the precise measurements and the method to turn those simple items into something special. The secret isn't just a list, it's a process, refined over a century, that turns common ingredients into one of the most recognizable tastes on Earth. Watching the bottling line is like watching a futuristic ballet. It starts with what look like small plastic test tubes, preforms. A machine heats them until they glow and soften. High-pressure air inflates the preform into a bottle in a split second. It happens so fast, you can barely see it. Newly made bottles are whisked away, clinking in perfect single file. Hundreds of bottles are rinsed, filled, capped, and labeled every minute. Automated, synchronized, monitored by sensors. If a bottle's off even slightly, an arm pushes it away. Operators run these multi-million-dollar machines from control rooms. They watch temperature, pressure, speed, and flow rates. If an alarm goes off, they diagnose and fix it fast. Downtime is expensive. Quality teams pull bottles constantly. Maintenance keeps everything running. Sanitation sterilizes every surface. Machines don't do it alone. If speed is one obsession at the factory, quality is the other. There's a lab right in the middle of it all. Bright, clean, full of instruments. Every 30 minutes, they grab fresh bottles for a barrage of tests. It's not optional, it's the process. Brix checks the sweetness. Carbonation levels are verified, machines compare chemical profiles to a digital standard, and trained human tasters catch the slightest off note. If anything's wrong, they can stop the entire line. Clean air, sterilized caps, and no-touch filling reduce contamination risk. They also screen for microbes. Cameras inspect every bottle. Cracks, foreign objects, label errors. Any failure is rejected. Zero tolerance. At billions of units, 99.9% isn't enough. It has to be 100%. Once a bottle is filled, capped, and labeled, its journey has just begun. Machines group bottles into 6-packs, 12-packs, 24-packs. Giant robot arms stack them with perfect geometry. Wrap, label, destination set. Now the clock is ticking. These pallets don't sit for long. Forklifts grab and load them onto waiting trucks. Trucks are the first link in a massive global supply chain. Some head to regional centers. Others go to ports and onto container ships. Coordinating all this is immense. That cold Coke, in your hand, was born on a line like this: loaded, transferred, warehoused, delivered, and stocked. Software keeps shelves stocked and products fresh. This distribution network is as much the secret as the formula. Reaching cities, towns, and remote villages. The factory is the heart. The supply chain is the circulatory system carrying it to the world. Visiting a modern bottling plant makes one thing crystal clear: this is a business of massive scale. Every minute, thousands of bottles are produced. Every day, millions of gallons of water and vast amounts of energy are consumed. For decades, the primary drivers of innovation in manufacturing were speed and cost, making more, faster, and for less. But operating at this scale in the 21st century comes with a profound responsibility. Today, the definition of efficiency is changing. The new challenge is to decouple growth from resource consumption. It's a fundamental shift in thinking, moving from a purely linear model of take, make, dispose, towards a more circular one. The question is no longer just, how fast can we make it, mob? But, how sustainably can we operate? This means re-examining every single step of the process we've just walked through, from the water coming in to the bottle going out. It starts with water, the primary ingredient. The question is, how do we make more with less? The answer lies in smart water stewardship. Inside the plant, water used for rinsing bottles and cleaning equipment is captured, treated on-site in dedicated facilities, and then reused for non-product purposes like utility systems, cooling towers, and general cleaning. This creates a closed loop that significantly reduces the plant's overall water footprint. The same scrutiny applies to energy. How do we use less? High-efficiency motors with variable frequency drives, or VFDs, are installed on pumps and conveyors. These smart drives adjust the motor's speed to match the exact demand, preventing the energy waste common in older, fixed-speed systems. Heat recovery systems capture waste heat from equipment like air compressors and use it to warm water for other processes. And to power it all, plants are increasingly turning to renewable sources. Some add vast solar arrays on their rooftops, generating clean electricity right where it's needed. Each of these initiatives, water reclamation, energy efficiency, renewable power, contributes to a single, overarching goal: to continuously reduce the environmental footprint of every single bottle produced. But the bottle itself presents the most visible and complex challenge of all. Packaging is the biggest challenge. Plastic, specifically PET, is an engineering marvel. It's cheap, lightweight, durable, and shatterproof. But these same qualities make it a persistent environmental problem when it's not properly managed. Tackling this requires a multi-pronged strategy. First is improving the bottle's life cycle. Companies are investing heavily in bottles made from 100% recycled plastic, known as rPET. This creates a market for collected plastic, turning waste into a valuable raw material and reducing the need for virgin petroleum-based plastic. Second is using less material in the first place. Through a process called lightweighting, engineers meticulously redesign bottles and caps, shaving off fractions of a gram of plastic without sacrificing strength or safety. Spread across billions of units, these small changes result in a massive reduction in total plastic use. Third is exploring alternative models. In some markets, refillable glass bottles are making a comeback. These bottles are designed for durability, returned by the consumer, and then sent through an intensive washing and inspection process to be refilled and reused dozens of times before being recycled. These efforts are part of a global ambition for a world without waste, a vision where, for every bottle sold, one is collected and recycled. It's a goal that extends far beyond the factory walls, requiring partnerships with communities, governments, and consumers to build effective collection systems. Beyond sustainability, the future is also about adaptation. Consumer preferences are evolving, with growing demand for drinks that have less sugar, different sweeteners, and new, more complex flavors. This requires a new level of agility on the factory floor. The answer is flexible manufacturing. Modern production lines are designed to be highly versatile, capable of quickly switching between different recipes, bottle shapes, and label formats. One system can now produce a huge variety of products, allowing the company to respond to changing tastes without building entirely new infrastructure. It's the final piece of the puzzle, a factory that is not only efficient and sustainable, but also agile and responsive to the world it serves.